Hey, so from whatever we learned last time, we're gonna make a tic-tac-toe game. Now, I know I said that we were gonna make snake, but I think tic-tac-toe is a little easier, so we'll do snake next time, like the next video, and we will do tic-tac-toe on this video. Now, this is what we had from the last video, and if you run this, we got this. Now let's go over functions first. Now, what are functions? Functions are well, you can say they're like pieces of code that are separated, and they can be called they can be used anywhere in your code. Something like this, look. Let's say we want to add a function to add two numbers. So we do int add. Okay, so what is this now? Look. Int is a variable type, right? That is the return type. What is a return type? I will show you now. Add is the function name. So when you want to call this function, you can just say add, and then you put in two numbers here, and then I'll show you. Okay, so let's do int a, int b. Now we'll say int result a plus b, and then we do return result. Now what this does is, if we go here and we say int my add result is equals to add 2 comma 3, we would have 5 in this. See, now if we do see out, my add result. Okay, now if we do this, not successful. Why is that? Oh, this has to be on top. And voila, we have 5. 3 plus 2 is 5. Now, okay, now let me show you what this is. So this add is the function name. That's how we called it here, right? That's how we called it here, using add. Int is the return type. So return is like returning to where you called it from. For this example, it's like int my add result. So now my add result would have this return result. Get it? So it's pretty easy, like, and whenever you do return and you say std cout hello after return. Now if you do this, this will not get executed because it will go inside the function, it will go to return, and it would go back here. It would not execute this. Now if I run this, you can see that, look, we only have 5. We don't have this. But if we shift this to the top, then we get that as well, see? Right? And notice how this is printed before. This is printed before this, because it goes here. So we call this, it goes inside add, it goes here, and it would do this, and then it would print this and return. So it would return this here, and then it would just print it over here. So that's how functions work basically. And you can have like all the stuff here. You can have bool, but then this, look, it will give me an error now. Oh, this is 1 because yeah. Boolean, okay. Yeah. So if you do like Boolean is 1 byte. But I'll explain you that later. Just this is not a valid thing actually, but it works because of the byte stuff. I'll explain that later. So let's just do int here. Now, yeah. So that's how functions work, right? So now, let's make tic-tac-toe. And do you know why I do this NL thing? This is like if I want to go to the next line. So now if I just do this, it wouldn't print anything. I mean, this one, it is undefined, so we don't need this. Look, it just goes to the next line. It's nothing more than that. So, yeah. So let's do tic-tac-toe now. What is tic-tac-toe? Well, it's a game where you have like 9 cells. So like 1, 2, 3, and then 4, 5, 6, and then 7, 8, 9. And then we can ask for an input from either player 1 or player 2. And then we need to change it appropriately, either O or X. One of the two things, right? So what do you need for this? We need an array, a 2-dimensional array. So now let's say int play area, and it's a 2-dimensional array, 3 rows and 3 columns. Right? Now let's make a function. Wow, this is nice. Let's make a function called void. Now void is no return type. So like you can return nothing if you want, or just don't return anything. Void init play area, and we do this on top so that the function can have access to it. Now we do remember for loops from the last video, and I is equals to 0, smaller than 3, I plus plus is same as like I is equals to I plus 1. So I've explained that in the last video, link in the description. This is, yeah, you can nest. You can do for inside a for, or you can do if inside a for, or you can do for inside an if. You can like nest it around. And j is equals to 0, j is smaller than 3, j plus plus. Now we can do, yeah. So let's print now. Let's print std cout, and then we do no, let's not print. Let's set the play area first. So this is init play area. So play area of I of j rows and columns. Let's name it rows and columns just in case. Rows, columns, Now this is rows and this is columns. Is equals to, now we can do, let's do 0. 0 is not it's not occupied yet. 0 is not occupied. We'll put it here. 0 is not occupied. 1 is occupied by player 1, and 2 is occupied by player 2. Now So 0 is not occupied, so we can just call init play area, and it would do that for us. And then we can like void draw play area. So drawing is just printing to the command line in this case. So we can even just copy this, really copy this, and instead of doing this, just print it. Now here's where some logic comes in. Now if we check if the play area of I of j is equals to 0, that means I mean rows and columns. Now if this point in the play area is not yet occupied, we have to print std cout. We have to print what? Let's print the number of the cell, right? So let's do, okay, let's do rows would be 0. So let's do 3. Okay, let's name another variable. Int play area number is equals to rows times 3 plus columns. Now what does this do? Well, think about it. Rows is gonna be 0 in the beginning, right? So 0 times 3 is 0. 0 plus columns, which is 0. So, and then we do plus 1 if we want to. So that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I'll show you. Wait. Let's do play area here. Play area number. And then after play area, we do std cout. std mf. Now, if we say draw play area, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool, right? And then we can even do like after printing this, we can do std let's do some spaces just to divide the play area nicely. Look, right? And then we can even do it more here as well. So 1, 2, 3, and we have a nice play area. Cool, right? Now how does this work? Well, look, rows is gonna be 0, 1, 2. Yeah, 0, 1, and 2, right? Columns is also gonna be 0, 1, and 2. Now in the first iteration of rows is gonna be 0. So 0 times 3 is 0. 0 plus columns. Now columns is like 0, 1, 2, right? So in the beginning this would be 0 plus 1. I mean 0 plus 0, which is 0. Then plus 1. So play area would be 1. Next iteration of columns, rows will still be the same. So now rows would be 0 times 3, which is 0. And then columns would be 1. So 0 plus 1 is 1. And then plus 1, which is 2. So the next thing would be 2. Get it? And then after printing this, and it would go, after printing this, and it would go here. And then after this, it would finish. And then it would add, just the same like last video, basically. Okay? Now, what is cool is we can do else if. This is what I was talking about in the last video. Now, we can check if the play area at that rows and columns is equals to 1, which means it is occupied by player 1. Now we want player 1 to be X. Okay, so let's do std cout. We do X, and then do the same thing. Else, we can do else now. because this would be player 2. It is occupied by player 2. Then we just say std cout. Oh, okay. Now check this out. If I say play area of 0, 0 is equals to 1, that means the first cell in the first row, I mean first column and first row is 1, which is occupied by player 1. So that would be X. See here? That's X. And then we can go X here as well and X here as well if we want. Let's do that actually. Play area of 1, 1. That's 1. And then play area of 2, 2. There's 1. Look, how cool is that? X, X, X. Cool? Now, let's get the game logic working. Let's get the game logic working. Now, let's see. Okay. So, well, what is a game? A game is essentially a program that does not end. That is a game, right? So now, let's make a while loop that goes forever. So while true. Okay? Now while true. Now this is a while loop that goes forever. Now if I run this, we can't even press anything. See, because it's running. This thing is not doing anything, but it is running. Now if I say something here, if I say something like std cout hello, look at this. It would just keep going. Okay? Essentially, a game is something like this. It doesn't end. This thing doesn't end. So now we can do many things here. We can, okay, look, we can init the play area, and then we can draw the play area on this. But after each draw, we need to clear. We need to clear the thing. We need to clear the thing. Now, how do you clear? Well, there's a command here. This is like platform specific stuff. So this works for Windows. If you do this, look. Yes, it would flicker, yes, because it's like clearing and drawing every time. But this won't be happening because we would have an input here. Let's make an input thing. So void, let's return, int input. Now our input would be int the input. Now how do you take an input from the user? This is how you take an input from the user. std cin, and it's a greater than sign instead of like smaller than over here in the cout. It's just the other way around. And say the input. Now we're assuming that everyone would input a number, the number of the cell that we're trying to put the X or the O. Okay, so let's return input. Now, let's return the input. Okay, now if we do an input here, and then we have an int my input. Okay, and then we can print. We can print this as well. So std cout. Your input is the input. I mean my input. Okay, now look at this. We can put the number 1 and enter. It would clear it. Yes, it would clear it. Let's do this. Oh, we have to do it. Yeah, it would clear it. Okay, let's clear it over here then. Oh yeah, it doesn't wait, man. Let's wait. Let's make it wait. Oh, the get car. Okay, just it's working. Just trust me, it's working. We can even do F flush. We can do F flush, right? F flush. And then we do get car. Cool. Now you will see it. There you go. Your input is 1, then you can do 2. Your input is 2. Okay? So yeah, don't worry about this F flush and everything. Don't worry about this. Don't worry about this. I mean, we will draw and we will clear the drawing thing here. Now, this is where our game logic would go in here. Now, we can even let's make a function. Void game logic. Oh yeah, by the way, notice how this is a function that returns void, and I do not have any return statements here. See, no return statements at all, because it's not returning anything. But if I do int here, and it would be an error. See, this is an error, right? And what is the error? Well, draw play area must return a value. It's over here. Okay, so we're just drawing here, we're not doing anything, so that's why it's a void. In case of the input, we're returning the input. That's why we are returning an int, which is the input. Okay, now let's do the game logic here. Well, let's have a boolean value. Bool. Which player? I mean, let's do bool player 1 is equals to true. So player 1 starts. Player 1 starts. Now we can do it here. Now look. If, or actually, yeah, we get an input, right? Game logic, and then we pass in int the input. Okay, so we have, and then we can just do it like this here. Game logic, my input. Cool. Now, in this way, we can have the input passed to another function, which is the game logic. Now, the game logic would do all the stuff. Well, now this is what the game logic would do. Okay, it would check if we are the first player, the first, what did I call it? Player 1. If player 1, then we wanna put an X. Okay. Else, now this is player 2, so we wanna put an O. Okay. Now we can check inside player 1. We can check if yeah, so we need to get the row and the column of the input. So let's make another function for that. Actually, let's not make another function. Let's do, yeah, Let's do it here. Int row is equals to, now what row is it? The input's gonna be 1 to 9, right? So we need to divide the input by the by 3. So so the input divided by 3. Okay. The input divided by 3. Yeah, the input divided by 3. Actually, I can draw the play area here, but then CLS would take it. Okay. Let's do, yeah, divide by 3. By doing that, we would have, look, if it's 1, then 1 divided by 3 would be 0 because it's an int. Int does not take like 1.2 or whatever. So this would be 0, right? So we get the row by just dividing by 3, really. Oh, actually, minus 1 divided by 3, because we did a plus 1. Minus 1 divided by 3. Now, yeah, so now we get the row. Now what is the column? And call is equals to, actually we can do this on top as well, so that both the functions will have things there. So now the input, okay, now, okay, look, we know the row here. Row is known. Okay, let's say row is 1, which is the input is 4. So now, what is column? Well, play area. So that minus row times 3. And then minus 1. Minus 1. Okay, that way we get the columns, right? This is the input. Okay? Now if the input is 4, row is 1, so 4 minus 3 is 1. 1 minus 1 is 0. That's perfect. That's perfect. Now if I do 5, then 5 minus 3 would be 2. 2 minus 1 would be 1. So that's perfect. Now we have the row and the column. Now we can do yeah, so now we can do, if play area of row and column is equals to 0, that means it is not occupied yet. It is not occupied yet. Then we would be able to do what? It is not occupied yet. Then yeah, we can occupy, right? So play area is equals to play area of row and column is equals to 1 because it's player 1, right? Now if it is occupied, else this is occupied. This is occupied. Well, we need to take another input, right? We need to take another input. So how do we do this now? So we can make another function. We can make another function that would tell us bool is occupied. and then we can put this on top of this, of the game logic. And is occupied, give me the and input, the input. And then we can just do this same thing. And then we can just see. So if play area of row and column is equals to 0, then we return false. Like it's not occupied, so is occupied would return false. Now else it would return, I mean, you don't even need to do else here, because if you just do return true, see, it would either return false or true. If it returns false, it will not return true because this will not get executed, like what I showed before. Now we can check it over here in the input. Now if, oh no, while is occupied, my input, then you would do it again. So my input would be equals to input. And then we can do a CLS and then draw again. So let's do a system CLS. And then we can draw again the play area. Okay. So now we have a thing to check if it's occupied. Now in the game logic, it will not be thing anymore, so it would be this would get executed, and then we just say 1, and then over here we can copy and paste the same thing, and then we would say 2. Okay, now if we run this, we say 1 x, see, 5 x. Now if we do 5 again, nothing would change, see, nothing would change. 9 x. Okay, that's pretty cool. We have like the basis of tic-tac-toe. Now in the game logic, we need to check okay, so now we just need to check, we need to make another function, void has won. Did someone win after moving? We need to know that, right? So now has won would check is anything there. So what player are we dealing with here? So we're dealing with player 1, so let's make another function as well to check. Now how do you win in tic-tac-toe? You win, what the hell is this? Must return a value. Let's do void first. Now, okay, how do you win in tic-tac-toe? You win by getting this line, or this, and this, or this line, or that line, like 1, 4, 7, 2, 5, 8, 3, 6, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 5, 9, 7, 5, 3. That's it. There's no more like winning condition. So we can just check it easily. Now we can just see if anybody has won. Now, bull has won. Now, after every move, when this happens, we need to change the thing. So we need to after game logic, we need to check has one, and this would return a bool. Result has one. Now we can just check if result is true, then we can just break. Now break, what does break do? Well, you see we're in a while loop that does not end. This is a while loop that does not end. If we break, it would directly go out, so it would not even like do anything on this as well. It wouldn't execute this line. So now we can just say std player. Now we can even just check here if the current player, if player 1, then player 1 1. Yay. And then we can just do a cn here. std cn. So we don't even need this. Let's just do this. Flush stdin, and then do a get car. Okay. Now else. If someone has one, so let's put the result on top of this. So go result is equals to false, and then result over here. You'll see why I'm doing this. Result and result, because it's possible that there are people like it's possible that the game ended without anyone winning, right? So we can do else if here. Result and player 2 and not player 1, which is, that means player 2 wins. So now we'll copy this and paste it here, and we do player 2 1. Yay. Else if not result, that means no one won. So std out. Oh no, no one won. Okay. Now, so yeah, we've handled that. Now has one result would break, or we can do an or here. Okay, let's do bool game ended. Okay, let's do bool game ended, and then we can just check if all the play area is already thing. So now we can do a bool flag. What is this? Well, if we can like iterate through the whole for loop thing, right? So we can take the for loop from here, copy this, paste it here. Now we can check for each play area. Now this, it will return flag. This if we need to check if everything is filled here. Okay, so now, return result. Let's do a result and a flag. Bool result. So we return a result. Now, for the flag, we'll say that it's true. It has ended. Now, if there's any one of the play area that is not occupied, that's equals to 0, then flag would be false. So we don't even need flag anymore. We just do result is false. Result is false. Now, see, result would be true in the beginning. It would go through everything, and it would see if there's anyone that's not occupied, then we haven't ended the game, so bool will be false here. Okay? But if everything has been occupied, then it would not execute this because nothing would be 0, right? So game has ended. Let's check that then. We can do OR here. Where's the OR? Game ended. On this. Oops, what's happening? Has one, must return a value. Let's do it. Has one, let's return false for now. Because nothing has one yet. So now let's do this. We do 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh no, no one has won. See? Everything is filled, but no one's won yet. Right. And then we can go here. To switch between player 1 and player 2, we just need to say player 1 is equals to not player 1. Not player 1 is player 2. And then it would keep going. So now if we do 1, 2, 3, pretty cool. 4, 5, 6, 7, 8, 9. Oh no, no one has won. No, no, no. And even before saying all these things, we can just, it's a CLS. We can do CLS and then CLS. System. CLS. And then we can even just draw it one more time. Draw play area one more time. Just to get the updated thing. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh no, no one has won. Cool? Cool. So now we have switched as well between player 1 and player 2 just by doing this one line of code, man. So, okay, what's next? Yeah, so we were checking if someone has won. How do we check if someone has won? Well, check horizontal. Okay? Now, we can do a for loop again. Let's do the same for loop again. Check if someone has won. Check horizontal. Well, this is columns. It's checking columns. So we can just do here, right? Like bool horizontal 1. Okay? Now we can see if someone has won. We'll say true here. And then we'll check it again. We can take... yes. Now, we need an integer to know what the first column in row. Okay, what is the value of that column? So play area of row and column is 0. Okay, rows and column is 0. And now what we can do is we can check each play area if play area of this is not equals to first column in the row first column in the row, then we know that it's not gonna be one line. It's like x0x or x00 or whatever. It's not one thing, right? So we know that horizontal one is false, because we know that it's a thing. Okay, so now if it actually reaches to true here, if horizontal one, then we would just return true. Someone has won, basically, and it's the current player who has won, because the last player has not done any input in this thing, right? Cool. So that's horizontal. That's checking horizontal. Notice how this rows is like following this, and it would go 0, 1, 2, and yeah, this would work very nicely. So now let's do check vertical. Check vertical. Okay. Check vertical. Now vertical 1, horizontal 1. I mean, what is it? First row in vertical. Now we're always going rows and then columns, right? For this we need to change. We need to go columns first. And then we need to go rows. Oh shit. Rows. Okay. Now this would be rows, which is 0, and then this would be columns, which is 1. Columns, which would be 0 as well in the beginning. And then we can check if rows and columns is not equals to this first row in vertical, then vertical 1 is false. Vertical 1 is false. Now if vertical 1, then we would return true. So we've checked the vertical and the horizontal now. Okay. Now this thing would go, yeah, very nice. Very nice. Now, yeah, so now we check the slanting ones. Let's check the slanting ones. So now if and also we have forgotten to check that it's not like it's filled. It has to be filled, otherwise how can anything won if it's not filled, right? So first column in row is not equals to 0, which means it is filled. And then do the same thing here. First row in vertical is not equals to 0, so it's filled. Now if the play area of 0, 0, which is the top leftmost, is not it's equals to play area of 1, 1, which is in the middle, and play area of 1, 1 is equals to play area of 2, 2. So this is like all the things are same and it is filled. So and play area of 0, 0 is not equals to 0. That means it is filled. Okay. Now this means we can return true. Someone has won, and it's the current player who has won, of course. And then we can do else. We can just do if again. we can do if, and then slanting. There are two slanting things, right? So let's look, check this out. Look, there are two slanting. There's this, and this, and we have this, and this as well, right? So we have done this, and we have done per row, and then we have done per column as well. But we haven't done this one thing. This is the last thing that we have to do, and our game would be done basically. So let's do this. Okay, now if play area, the last play area, which is last row, which is 2, and then first column, which is 0, is equals to play area of column 1 and column 1, that's in the middle, and play area of 1 1 is equals to play area of 0 2, which is on the top rightmost, and play area of 2 0 is not equals to 0, which means it is filled, and then we can do return true. That's it. That's it. That's our game. Right? That's it. That's our game. It's done. 1. Oh shit. How did this win? The fuck? Okay, so I have solved it, and I was being a little stupid. This is like, we need to change this to or, and we need to change this to is equals to instead. Why? Because if the first column in this particular row is still not filled, then this doesn't matter at all, right? This doesn't matter at all. It would still be false. And the same thing with this then. It has to be or, and this has to be equals to. Now why? Same thing. So if the first element in this column, if the first element in this column is still not occupied yet, then then this is not possible. Like, we can't win. So yeah. And then this was for debugging. So yeah, now we have the game and everything works well. Let's try it out. Let's do this. 1 x 2. Oh, if we do 2 again, oh no, it wouldn't put it. It wouldn't put it, see? If we do 3 x, see? Now if we do, let's see, let's make player 2 win. So 5, that's O, 6, and 8. Now it should say player 2 win. Because O, O, O. Here, O, O, O. Let's try again. Let's try again. Let's make player 1 win this time. So 1, 5, 2, 8, 3. Player 1 won. Yay! Let's try again. Let's try 7, 5, 3. Let's make some player win. So let's do player 1. 8. So 5, 6, and 3. Voila. Right? Now, yeah, this will just work. This will just work. Let's do 3, 6, 5, 7. I mean 8. Let's do 7. this will just work because the algorithm's pretty cool, right? Like, yeah, so that's how you make tic-tac-toe. Pretty simple. Well, F flush. This is a platform. No, this is when you put something, like when you type something in your keyboard and you press enter. If you type more than one stuff, it would be like some of it would still be there in the buffer. So we need to flush the buffer to clean it, so that at the end we can just press enter and the program would quit. Cool. And then let's make no one win now. Let's make 1, 2, 3. Let's do 5. Let's do 8. Let's do 6. Let's do 4. Let's do 9. And let's do 7. How did... Oh shit. Okay, player 1, this, and this. Player 1, 1. Let's try again. Let's make no one win. Let's do 1. Let's do 5. Let's do 9. Let's do 8. Let's do 2. Let's do 3. Let's do 7. Let's do 4. And let's do 6. Oh no, no one won. See, no, nothing is there. Look. Pretty cool, right? So we got tic-tac-toe working. Next time, we will make snake. Peace.